Hello. In the previous videos, we did descriptive data and set theories, which were things that you did in grade 12, and we were just revising and showing you how some of them have changed or advanced from grade 12 to the level you are in right now. So today we'll be doing counting methods, and this means that we are a step closer to probability. So a permutation says a different arrangement of items. So permutation is a way that we can arrange different items. So having n unique items, we can arrange them by n factorial arrangements. So it says, but sometimes you just need a few. So by that I meant that sometimes you'll be given n amount of items and you just have to choose, or you just have to arrange a few from those items, not all of them. So here, I don't know, I just wrote rules for permutation. I don't know what they call those steps. So most of the time we have n different items, and R is the number of items to be arranged out of the n different items. So as an engineering student, by now you know that hashtag represents number in our field. So arrangement or order matters in permutation. So n permute R equals to n factorial divided by n minus R in bracket factorial. So as I told you that order matters in permutation, so the two examples we have here, A, B, C, D and A, C, B, D. In permutation, those things we take them as different arrangements or as different things because the order of the items matters in permutation. In combination, order doesn't matter. So most of the time in combinations we have n distinct items and you can select R items, and arrangement doesn't matter. So ABC is the same as CAB or BAC in combinations because the order doesn't really matter. So n choose R equals to n factorial divided by n minus R factorial times R factorial. So counting method, this is just a summary of all the things I've been saying. These are the formulas in your slides that you are familiar with right now. This is n choose R, where I've already shown you this formula, and again you can represent it in terms of permutation by saying that it is equals to n permute R divided by R factorial. So from class or from your lectures, you've seen some of the gentleman agreements, such as 0 factorial equals to 1, n permute 0 equals to 1 also. So using this calculator, our factorial symbol, or where you can find factorial, is in this button here under modes. So using this calculator, when you are using the permutation formula, you are going to press n, where n is any number you'll be dealing with, and then you are going to say shift multiplication sign and then press R, which is any number that you will have in your equation. So this is shift and then the multiplication sign. So it's like, let's say you had 7 permute 5, you will press 7 shift multiplication sign 5, then equals to, you will get your answer. So when using the combination formula, you are going to press N, which is any number, shift division sign, R. So using a calculator, let's say you had 7, choose 5 again, you will press 7, shift division sign, 5 equals to, then you will get your answer. So we also have the multiplication rule. So it says if you have one event that can occur in n ways and another event with m ways, then together they occur n times m ways. This is the fundamental counting rule, which they've given you as the multiplication rule in your lectures, and I'm aware that it is a bit different, but this one and that one in your lecture slides mean the same thing, or they say the same thing in different ways. So we have an example here on how to use the multiplication rule, which is the counting rule. So you are given a toy manufacturer makes a wooden toy in the parts. The top part may be colored red, blue, and white. The bottom part brown, orange, yellow, or white as well. How many different colored toys may be produced by the manufacturer? So here we were just doing it manually. You don't have to do that now. So using the counting principle or the multiplication rule, which told us that if we have two events occurring and the other one is occurring n times and the other one m times, together they occur n times m ways, meaning that here we have the first event where the top part can be colored in 3 ways: red, blue, or white, and the bottom part can be colored in 4 ways. So using the counting rule, which is the multiplication rule, our sample space will be 3 times 4, which is equals to 12. You can do it manually like this, and you will still get 12, right? Example number 2 says 2 cards are drawn one after another at random from a standard deck 52 cards. A says, in how many ways can a 7, then a club, be drawn if the 2 cards are drawn without replacement? So this question required you to know that we have 52 cards in a standard deck, like after removing all the jokes, and from each card has 4 cards. I don't know if I'm making sense. Let's say we have 4 aces, we have 4 kings, and blah blah blah. And of the 4 cards of let's say kings or queens, we know that we have one that has a spade, hearts, diamond, and clubs. So it just required you to know these things here. So A said, in how many ways can a 7 and then a club be drawn if the 2 cards are drawn without replacement? So without replacement means that if you've taken out a card, you won't put it back into the deck when you are choosing for the second time. It means that you will just take it out and then put it aside and perform the next event. So you have to think about it. So now you know that there's a 7 that is also a club, right? So you have to think about this like in real life. So now in this case we will have cases that, okay, let's say maybe 7 club not drawn in the first instance. Let's say the first instance, when you try to take out a 7, you will draw out a 7, but not the 7 that has a club. So how many ways can you choose a 7 that is not a club? 3 ways, because you can choose a 7 with a heart, with a diamond, or with a spade. So we will have 3. Now event number 2 is that we have to choose a club. So we will say times 13, because of the different 13 cards, each has a club. So you know that you can choose a club. Maybe you can choose a king that has a club or a queen that has a club. Like there's 13 ways you can choose a club from the deck. So case number 1, you will have 3 times 13 equals to 39. So in case number 2, we are assuming that, okay, let's say you choose a 7 that is a club the first time. In how many ways can you choose a 7 that is a club? Once, because we only have one card that is a 7 and a club, right? So it will be 1. And now remember, you assumed that you've removed that 7, which is a club, so you've taken it out. So what's going to happen, it means that now of the cards that are remaining, 12 of them are clubs from the different cards, because you've removed the 7 club, right? So it means we have 12 clubs remaining of all the cards. So it will be 1 times 12, which is equals to 12. So your sample space now, the total ways in which you can choose, what was the question saying? In which you can choose a 7, then a club, without replacement is equals to 51. So what happens if they said with replacement? So with replacement, the first case was going to be the same, but the second case is different. Why? Because in the second case, the 7 that you withdrew, there was a club, you are going to put it back. You are going to replace it again and put it in your deck of cards. So now you've got 13 clubs in the deck again, because you replaced that one. So you are going to have 1 times 13. So your sample space now is 52, because you are going to add the first case with the second case, right? So B says, in how many ways can at least one spade be drawn if cards are drawn with replacement? So this one says that in how many ways can at least one spade be drawn if cards are drawn with replacement. So there will be replacement of cards, and it says that we can have at least one spade. So the minimum number of spades we can have is 1, right? So B was asking us that in how many ways can at least one spade be drawn out. So again, we will have cases. So our first case, it's a case where we say, okay, let's say maybe when we are drawing this time, let's say the first card we take out is a spade, and the second card is just another type, maybe a heart or a diamond, right? So I've got 2 conditions here. I've got the solution without replacement and with replacement. So without replacement, so without replacing the card, it will be, we have 13 cards that are spade that we can choose, times so now we assume that now we can draw any other card that is not a spade. So we know that if we have 13 spades, so the chances of choosing another card that is not a spade is 52 minus 13. So that's how we got the 39 here, because there are 39 ways we can choose a card that is not a spade. So there's our first answer. And case number 2, we are saying that, okay, what if the first card we draw, it's not a spade, it's just another card, and then the second one is a spade. So remember, order matters. Order matters. I told you in the beginning of the solution that order matters in this case, because you can't say that you are drawing card number 2 without drawing card number 1 first. So order matters, guys. So how many ways can we draw a card that is not a spade? It's still 39 times 13, right? 13 for the spades. So it's still the same, it's just that the order is different, and the order matters. We should account for that also. And case 3 says, what if we withdraw a spade, then a spade? So without replacement, we will say 13, right? And then we've took out 1 spade. So it means in the deck we have 12 spades remaining. So it's going to be times 12 equals to this. So the last case that says spade and a spade. So I explained in the beginning that the question, you even saw that I underlined at least 1, because it is saying that let's say the minimum number of spades that we can have in a draw is 1. So we know that you can see that here we have 1, here we have 1, here we have 2. So this case still counts, because there at least in the statement means that we should have a minimum of 1. So having 2, it's not a train smash. You can have 2, is possible. And with replacement now, it means the cards will draw out a card and put it back in the deck for the next draw. So case 1 and 2 is still the same, but case 3 has changed, because if you draw a spade, you have 13 times, or you have 13 different ways you can take out a spade, times, now remember that spade we drew out, we've put it back in the deck. So now we still have 13 spades, because that one we replaced it. So we will say times 13, which will give us that. So you can see that the sample space of without replacement is 1170, and with replacement is 1183. Right. So it says a 3-digit number is supposed to be formed by selecting 3 digits without repetition from the digits 0, 1, 2, 3, 4, 5, 6. A says, how many of the numbers will have a number value between 100 and 500? So remember that they said without repetition, and they also said a 3-digit number. So guys, you know that. So this question says how many of the numbers will have a number value between 100 and 500. So we have the digits here. I've written them here. So now so we are going to make space for 3 different positions, and then what you are going to do is, okay, so they are saying numbers between 100 and 500. So it means that you can choose 1, 2, 3, 4. Because the minute you choose 5, you are wrong, because they said the numbers should be between 100 and 500. They did not say 500 included, right? So 500 and 100 is not inclusive in this case, right? So you will have 4 times. Here now we have to choose again. So remember, they said that no repetition, right? So now here we have 1, 2, 3, 4, 5, 6, 7, 8 digits, but one of it we chose it here, so we are going for the second digit. We are going to have 7 digits to choose from to make a number, right? And then of the 7, now we chose 1 that is here now, and then we are going to choose from the 6 remaining numbers. We are going to choose the last digits from the 6 remaining numbers, because they said no repetition, guys. So B says, how many of the numbers will be even? So this one, you know that even numbers, it's either they end with 0, 2, 4, 6. So we will have different cases. So case number 1 will be the case where the even number is ending with a 0. Why did we make ending with a 0 a special case? Remember, they said 3-digit number. So we know that every time we choose for the first digit, we cannot include 0, because if you start with a 0, now you won't meet the condition that says a 3-digit number. The minute, because guys, 0 to 0 is 20. Those are two. It's a 2-digit number. It's not a 3-digit number. So you should make sure that you don't start with a 0. So that's why we made 0 a special case, ending with 0 a special case on its own. So in the first position, we have 1, 2, 3, 4, 5, 6, 7 numbers to choose from. So we can choose one of the 7 to start our digit, our number. So obviously we said ending with a 0. So the last one here, how many times or how many different ways can we choose 0? Once, guys. We can, it's 1. And then for the second one, now remember that you've already chose 0 here. This one is here because you know that your number is ending with a 0, and you've chosen one digit that is going to start your number. There's 7 digits you can choose from. So now from the 7, you are going to ignore or remove the one that you've chosen and choose from the remaining 6 digits, because we are trying to meet the conditions that says without repetition. So you are going to have 7 times 6 times 1 equals to 42. And case number 2 is even numbers that end with 2, 4, or 6. So we know that they are ending with either 2 or 4 or 6. So that's why in the last position we have 3, because you can choose 2 or 4 or 6. There are 3 different ways you can choose the last number or digit. Sorry. So now you've chosen the last number to be one of those, 2 or 4 or 6. So the first number now, you will be left with 6 digits to choose from. Why? Remember, you can't start your number with 0, so 0 is out of the way. And from these three you've chosen one, so you remove that one, so you'll be left with, let's say in this position we chose a 2, so you'll be left with 1 2 3 4 5 6 digits to choose from. That's why we have a 6 here. So here again, you know that you will remove the 2 that you chose here, if maybe you chose it, and you will remove the digit that you chose in the first place. But remember, here when we chose, we disregarded the 0. So here when we choose, we will include the 0, and then we are going to have 6 digits. That's how we got the 6. So case number 2 is 6 times 6 times 3, which is 108, and the sample space is 42. Case 1 plus case 2 equals to 150. So the next example is from formation of permutations using r things taken from n different things. So the theorem says the number of permutations that can be formed by arranging r items taken from a group of n different items in a row, the sample space equals to n permute r. So I won't go into detail explaining that theorem, but we'll just do examples under that. It says 4 people, Anna, Brian, Collins, and Diana, are available to form a committee of 4 people comprising of positions A, chairperson, B, secretary, treasurer, and spokesperson. So it says each one can take up only one position on the committee. How many possible committees can be formed? So the condition that says each one can take up only one position on the committee is very important. So that's the only condition that we have to meet. So this is how we do it. Right, so we have 4 positions and we have 4 people. Remember, from the intro, we said that to arrange n unique items, you can arrange them by saying n factorial arrangement. So we have 4 people that have to fill 4 positions. So we can say 4 factorial. So how do we come up with that? So we are saying, okay, we have 4 positions. When we have 4 positions, if now for the first position we have 4 people we can choose from, choose the suitable person for the job from 4 people, right? Now this one has been chosen. One has been chosen from the 4. So now it means for the second position we are left with 3 people who we can choose from, right? We are left with 3 people, so now we can choose from 3 people. Times now 2 people are gone, they have the position, so now we are left with 2 people to choose from. So 2 people can fill this position. And then the last one is an obvious, so you're like, okay, you're the only one who's remaining, so you can fill up the space. So this is how we come up with this. You can see that 4 times 3 times 2 times 1 equals to 4 factorial, where 4 factorial equals to 24, right? So the second example says, assuming that any sequence of letters is a word, right? Find the number of words that can be formed by letters in the word triangle that starts with A and ends with a T or L if all 8 letters are to be used. So from the question, they said if all 8 letters are to be used. So you know that the words that we are forming, or the word that we are forming, has to have 8 different letters, because triangle has 8 letters. And we have a condition. So guys, every time we answer these questions, we start with the conditions and then we can do the rest. So the first condition said the words or the word should start with an A, right? So the word should start with an A. There's only one A here. There's only one A we can choose from. So we are just going to say 1, right? And then condition number 2 says the words should end with either T or L. So we come to the last position. So the last position can either be an L or a T. So we have 2 different letters to choose from. So this one we are going to say it's a 2, because it's like we are saying from 2 letters choose one and then put it in that position. Put it in that position. So 2 choose 1 times 1 equals to 2. That's how we got that 2, because from the 2 letters we are going to choose 1 and then we are just going to place it here, which is 1, or you can say 1 factorial, which is still 1. So with this one also we have 1A. So we are going to say 1A. From the 1A, choose 1 times 1. It is still 1. So that's why I was like, here it's a 1. So here we have 2. And then here, from the remaining numbers, you can do it as we've been doing it, that, okay, in the first position you have 6 letters to choose from. And if you chose this one, you can choose, right? But we know that we know that arranging n unique items is 6 factorial, right? So we know that here now from the remaining, because if you choose 1 and 1, you'll be left with 6 letters that now you can choose from to complete your weights. So you can just say 6 factorial. So your sample space is equals to 1 times 6 factorial times 2, which is 1440. The other example says 6 people, Anna, Brian, Collins, Dineo, Alsabe, and Julius, are members of a club. They wish to form a committee of 4 people comprising of positions: chairperson, secretary, treasurer, and spokesperson. Each one can take up only 1 position on the committee. How many possible committees can be formed if Julius has been declared ineligible to becoming the treasurer? So guys, we have 6 people, we have 4 positions, and they are saying that one is not allowed to be chosen as a treasurer, and it is saying that each one can take up only 1 position. So those are our conditions, right? Make sure that your answer meets the conditions. So guys, we have 4 positions. So we have a condition that says Julius has been declared ineligible to become the treasurer. So let's say maybe this position is the position of a treasurer. So I'll say maybe this position is for treasurer. So to meet this condition, so because we have 6 people now, we have 6 people, né? But Julius cannot be a treasurer. Maybe they know that he'll eat the money or something, so they are disregarding him in that position. So you know that you are left with 5 people to choose from now to become treasurers. So what we are going to say is 5 choose 1. So from the 5 people, Anna, Brian, Collins, Dineo, and Alsabe, we can choose from them. And so it's 5 choose 1 times 1. So from the 5 people, we can choose 1 to fill one position of being a treasurer. That's how we came up with this, right? So that was the condition. So for the other three, they did not say anything special or any condition or any restriction. So for those, we are saying now, okay, because one got the job and they said, remember the condition, each one can take up only one position. So from the 5, 1 is a treasurer now. So let's say Anna was a treasurer, was taken to be the treasurer. So we know that of the 3 positions that are left, we are not going to consider Anna. But now Julius is back. For the others, he can apply. So now we are going to have 5 people disregarding Anna, because Anna now is the treasurer. So we are going to say from the 5 people, we are going to choose 3 and put them in the different position, in their different positions. So we are going to arrange them in the positions by 3 factorial. So we are going to say from the 5 people, choose 3. So choose 3. So now you have 3 people. You've chosen the 3 people. They are here, just standing there. So now you are saying, okay, I'm going to arrange them in their different positions. You arrange them how? How do you arrange them? By saying 3 factorial. Because if you choose here, you will say 3, 2, 1, right? So this term is the same as 5 permute 3. So after this condition, you would have just said 5 permute 3, because from n people 5, you want to choose r people 3. So you are going to say 5 permute 3. So 5 choose 1 times 1 is the same as 5. So our sample space is 5 times 5 permute 3, which is 300. Or someone just doesn't get the first solution. You don't know what was going on, or you were not familiar with permutations and choosing and what. So you could have just showed us your 4 positions and say, okay, remember the first position was a treasurer. So and you said from 5 people now, I can choose a treasurer from 5 people. Then you will say 5 times. Remember now, after Anna was the treasurer, we removed her, but Julius was still there. So now, considering the other 5 without Anna, who was chosen as the treasurer, you are going to say, so here I have 5 people to choose from, and then after you get the relevant person for that position, you are going to say, for this one, I have 4 people to choose from, times, and then after you get 1, for the last position, I have 3 people I can choose from, and then your answer is going to be 300. So there are 2 ways you can answer that question. So the last question says, suppose that an ordinary South African registration number plate has 3 different letters followed by 3 digits and then a letter for the province in which the vehicle was registered. The letter O and I may not be used. What is the total number of ordinary number plates that can be issued to motorists in South Africa? So, in this question, what you need to know is your English, guys. You need to know and understand your English and know how many letters we have in total, how many digits we have, and how many provinces we have in South Africa. So you know that we have 26 letters, né? We have 26 letters, but there's a condition that says O and I may not be used, right? So here they say 3 letters, so I have spaces for 3 different positions, and then they said followed by a 3-digit number. I have 3 different positions for digits, and then they said and a letter for a province, and then I have a space for province there. So now they said that in the statement they said 3 different letters, meaning that we cannot repeat letters. So from the 26 letters we minus 2 because O and I are not supposed to be used, so we'll be left with 24 letters. And remember that we are not supposed to repeat them because they say different, right? So we are going to say we can choose from 24 letters, and then after 1 is chosen we can choose from 23. After 1 is chosen we can choose from 22 letters because repetition is not allowed. And then for the digits, they only told you that 3 followed by 3 digits. They didn't say anything, so meaning that whether they repeat or they don't care. They are not worried about that. So we have 10 digits we can choose from: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 digits we can choose from. So it's going to be 10 times 10 times 10, because they didn't say anything about repetition. So it means it's fine, you are allowed to repeat. So now here it is, you treat it as a condition of with replacement, right? And then we have 9 provinces. Yeah, we have 9 provinces in South Africa. So your sample space, it's 24 times 23 times 22 times 10 times 10 times 10 times 9, and it will give you this number: 109,296,000, which is 109,296,000.